The brakes of the car is that one part that you are responsible for somebody's life.
The forces and moments that act on the car at those speeds are phenomenal.
You first have to understand the problem. It's hard to describe.
It's pure physics.
You need to have the best possible part when you're ready to put it on the race car.
It feels very liberating and it feels petrifying.
You're not only trying to find an accurate solution, but you're trying to do it in the most efficient manner possible.
Just put them on the car and drive as fast as you can.
And you have to get it right.
It's very difficult to simplify it. It's the best thing for you to come where I'm standing so that you can see the brake duct. Okay. So this is the inlet of the brake duct. It's where all the air enters. The role of the brake duct is simply to cool the braking components.
If you get it right, nobody really notices, but if you don't get it right, everybody knows.
I hope you never hear anything about the brake duct outside of this video. If you hear anything about the brake ducts, it's probably because there's an issue. So fingers crossed.
So the steps in the process start with simple whiteboarding. What are our objectives? What are the requirements? And at the end of the day, what do we want to produce?
Are you kidding me right now? It's hard to see from this view, but anyways, the wind passing the car would go inside the tire wall, okay, and into this. And once it comes in here, there's where all the magic happens, because there's tremendous amounts of heat at the center of this, where the disc is and the caliper are working together to bring the car to a stop. So this thing gets glowing hot, like orange, red, yellow, all kinds of fun colors hot. And we want to make sure that A, it doesn't melt itself, and B, it doesn't melt all the things adjacent to it. FIA rules are very strict. None of the air that's cooling in here may escape out the outside of the wheel. So once we get an idea of where the ducts are going to go, so we start making our own CAD models, and they have to make it into real parts that can really be manufactured.
In CAD land and in Rapid Prototype, you can do anything. The general purpose of what we're doing is to make sure that the car keeps going as fast as it can. I suppose we could say that what I've got on screen right now is the brake duct that we've assembled in order to prove out a disc and caliper and pad package that hasn't been used before on any motor vehicle.
So you're the brake duct guy?
I'm one of many brake duct people, yes.
The aero designers, they are going to dictate certain things about the design of the brakes.
So every inch of this has to be designed, I guess, by someone.
Absolutely. And we are operating within a space that has a lot of constraints and restrictions. So here on screen we have a representation of our surface model, complete with the rim. These green volumes are a representation of the spaces we have to work with.
And then we calculate what the air is doing on each of those boxes.
In the surfacing design phase, we use CFD to model the airflow entering the brake duct.
And get some understanding of where I landed in terms of numbers.
Once we've gotten all of the parts from the designers, then we'll bring them into our CFD software here.
So Jake's the CFD guy.
He is quite the whiz with the simulation tools.
Who has the worst desk?
Me.
Oh.
We take a 3D representative object and we chop it into little blocks. We'll take the little bit of very milky coffee and we'll essentially create blocks that will represent that 3D geometry. So we'll have the coffee, we'll have the air on top of it. Those blocks are where we solve equations. The beauty of Formula One is attention to detail. And so in the case of the brakes, right, we have the pads that get hot, we have the disc that gets hot, we have the caliper that is less hot. So we assign temperatures to those, and then we will simulate the airflow through. We have to then start sharing 3D geometries with design to go, okay, do you think this is manufacturable?
And then once they're good and get their numbers where they think they're happy for the cooling range they want to run at, they kick it off to us and we take their surfaces and see what we got to do to make actual physical parts work.
So this is generally the full assembly that we'll get from Aero. We'll pretty much take this and do a lot of conceptualizing. We try to respect the Aero surfaces.
Yeah, like we kind of take them as gospel unless we're told we can't.
There'll be some back and forth with us on what we can change to make all the splits work. We care about materials and assembly and manufacturing. So there's a lot of planning and work that goes in to make it fit together nicely. That's what we get. So this is the finished brake duct.
We go from, I think that's like 13 pieces to almost like 60. We'll get sign off on the design, then we start making the laminate drawings. So the instructions on how to make the part.
We send our CAD files to Scott. Scott prints it. Scott's great at his job.
Zack, are we ready to give this a whirl? I'm gonna go ahead and hit that.
This is the software that we use to actually prepare it to go on the Neo. These are printed as individual pieces. There's no assembly of these pieces. No, this drum initially came in as 18 different pieces. We want just a singular solid piece. So this will literally print exactly. Correct, yep.
Let's go check it out in the actual printer itself.
So we're good to pull this guy off. So it's gonna get unloaded off of that machine and then put into this machine that will clean all of the uncured resin off of the part. Slide this guy in. You can see the uncured resin that's still sitting all on top of these parts, like it's what's got this sheen on it. So what this machine does is it's gonna dunk the parts. It will swirl the fluid and it has ultrasonics in it that will literally also vibrate that fluid and dissolve any of the uncured resin out of like interior channels. Yeah, that's pretty much it. So that's gonna get rolling for 20 minutes or so. Normally I will let it drip dry after it comes out of that as well, so they're not just covered in the wash tank fluid. It's less of a mess. Pretty much the next step on all of this is just gonna be pulling all of this off. So this could take a while. The mic is gonna have a good time picking me up. This is like a 2-bucket method, like if you were washing a car. Once it's dry, we'll put it in the curing oven to make the resin actually safe to handle. That's pretty much what the process looks like.
So after the parts were done printing, they got test fit together. So this is one representation of a way we can look at the results we had at the dyno.
The dyno basically, from my understanding, lets you model things in a real world setting without having to put a car on a track.
So the dynamometer we used allowed us to really simulate what the brake duct, the brakes in that corner of the car would do on track. We were looking at absolute results, like when we do this to the brakes, how hot do they get? But also, if we swap this part out, does that change the results? These are monitoring various points on each face of the disc. So this is 900 seconds, 15 minutes of going through various laps of a specific racetrack. We got to see the response of the real parts to these different aerodynamic changes that we're making. Helps us understand more closely what the real car will do. The results were excellent in the sense that any real world data will be a plus, because we started with nothing.
Every other F1 team has that real world data from past cars. Cadillac Formula 1 does not. If we're zooming out now and we've understood one cycle, can you paint a picture to the viewer of how many additional cycles happen after this that they're not gonna see?
Hundreds, like even low 1,000.
We're probably in almost 300 iterations of this so far.
There are gonna be hundreds, if not thousands.
Got a big question for you. Sure. How do you design an F1 car?
That's a good question. First, you got to know what all your objectives are.
One piece at a time. As a team, you know, it's a lot of people coming together to build one car, essentially.
If you had to guess, how many pieces in that F1 car are there?
Thousands.
too many.
A Formula One car is constructed of tens of thousands of different individual parts.
I still cannot believe how much time and effort goes into just one iteration of one component of the car. There's concepting, there's surface designing, there's CFD simulating, there's 100 back and forths just between surface designing and CFD simulating. Then there's the handoff from aero to design, where the designers then have to add dozens of components to the actual surface design to make it manufacturable. And then they have to go and either print it, test it, and then you zoom out, and the brake duct is like one star in an entire galaxy of pieces that need to be made that require just as much time and manpower to assemble the final Formula One car. It really is a staggering amount of work. And with that, we'll see you in the next one.